our respected Vice Chancellor, Madam Professor Dr. Balwinder Shukla, I, Kamakshi Parsai, a proud member of SNT War Room, extend a heartfelt welcome to you all. We are delighted to come together as part of the India Space Week 2026, organized by Amity University, Uttar Pradesh, in collaboration with Indian Space Association. At Amity, we are committed to being an active part of this transformative journey through the Amity Space Mission, a comprehensive initiative focused on advancing space education, research, innovation, technology development, and industry collaboration. Under the guidance of our Honorable Founder President, Sir, this mission seeks to inspire our students and researchers across all Amity universities and international schools to explore new frontiers, develop innovative solutions, and contribute meaningfully to India's growing space ecosystem. It is therefore a privilege to invite on the dais the eminent leaders and experts who have made significant contribution to India's space ecosystem. Lieutenant General A.K. Bhatt, Sir, PVSM, UISM, AVSM, SM, VSM, Director General, Indian Space Association, Air Vice Marshal Pawan Kumar, former Director General, Defense Space Agency, Dr. Sudhir Kumar, former Director, CBPO, ISRO, and Vice President, XD Link, respected Vice Chancellor, Madam Professor Dr. Balwinder Shukla, and Dr. K.M. Soni, Sir, Dean, PhD Programs, AUP, Professor, and Deputy Dean, Engineering and Technology. I kindly request all the esteemed members to kindly join us on the dais. A huge round of applause for all the delegations present here. I request all the students. A big round of applause for all the members present here. Before we formally commence to today's program, I request respected Vice Chancellor Madam to kindly welcome the guest with the Tulsi sapling as a symbol of warmth and shared commitment to sustainability. A huge round of applause for Lieutenant General A.K. Bhatt. To Dr. Sudhir Kumar, Sir. To Air Vice Marshal Pawan Kumar, Sir. A huge round of applause. To formally inaugurate today's program, I have the privilege of inviting Professor Dr. Balwinder Shukla, Ma'am, Honorable Vice Chancellor, Amity University, Uttar Pradesh, to deliver the opening remarks. May I kindly request you, ma'am, to please address the gathering.
Our most respected Honorable Founder President, Honorable Chancellor, our esteemed guest Lieutenant General A.K. Bhattji, Director General Indian Space Association, Air Vice Marshal Pawan Kumarji, former Director General Defense Space Agency, and all the distinguished guests on the dais, as well as our session chair, the moderator, Dr. Sudhir Kumarji, Vice President, XD-Link Space Labs, all the distinguished guests in the audience, front rows, my colleagues, and very dear future scientists. First of all, I, on behalf of Honorable Founder President, Honorable Chancellor, Additional Provises, Deans, Head of Institutions, and my personal behalf, I extend a very warm welcome to our distinguished guests, the partners for the celebration of India Space Week at MIT University, Uttar Pradesh, in collaboration with Indian Space Association during the 14th to 18th August. My team here at university, all have been engaged since 14th of August, organizing different activities. And today we have the even the exhibition by the not only by the university students but the school students also. And the ideas which they have are amazing. And I think what our honorable founder president always dreams, this talent, the youth will be coming the solutions which are aligned with the national priorities, which are the aligned with the societal needs, and contribute to the nation building. And I can understand that at the campus in the, as I said, in the last few days, has been very, very vibrant platform. The various ideas, innovations, curiosity, and meaningful conversations around India's growing space ecosystem, organized in the collaboration with the Indian Space Association and technical partner Synodic Space Education. And this whole celebration week celebration is the initiative themed space education and the research. And it is the tribute to the visionary leader, the legacy of Dr. Vikram Sarabhai and reflects our shared commitment to nurturing the next generation through space education, research, innovation, entrepreneurship, and stronger academic industry partnership. It is in this spirit of collaboration and collective aspiration that we gather to celebrate this is important um, event. The today the project, as I said, showcase the competition and space science exhibition has further enriched the celebration. More than 80 students in the morning, myself and Dr. Nan, two of us visited. We could not visit every single exhibition, few we visited, but we found that kind of the ideas and the projects which are developed by the students, that there's some of them are the models, some are the prototypes, some are the simulation, and posters across space communications, AI, robotics, aerospace, and other emerging technologies, whether the students are from the biotechnology background or they are from the space science or engineering and technology or aerospace or other areas, because the university has, university being the multidisciplinary university, we have the students except hardcore medicine, all other discipline we have, and we saw that interdisciplinary kind of approach also the student. And we also were thrilled to see 50 plus students from MIT International Schools who participated in and displayed their innovative projects. creating a valuable continuum between the school level curiosity and the university level education innovation. And these activities have provided our students an experiential, interdisciplinary, and the innovation oriented learning, taking them beyond the classroom concepts. And I remember that some of the students, what the idea they have presented in the international conferences, and they are now looking at how those their idea take to the governments, the state governments, and how that land, which is very stable but it's not being otherwise used by the forest, how the new cities and how new townships can be established, or the how the the from the biotechnology that the students are working at how the diatoms and other energy, how they can bring out the new solutions which is that today our society is looking for. And I would like to briefly highlight also the Amity Space mission being led under the visionary guidance of our Honorable Founder President, sir. Over the past 2 years, we have undertaken several initiatives to strengthen Amity's engagement with the national space ecosystem via collaboration with and ISPA and the participate in space and defense space events as a knowledge partner, engaged and conducted various space in space, and our scientists are pushing research work collaboration with ISRO and space industries. And these efforts reflect our sincere commitment to building a meaningful and sustained presence in the space domain. I remember our honorable founder president about 2 years back when we were having our international conference spin. And at that time, when the former chairman of ISRO was also present, Sri Somnathji and their honorable founder president committed that the Amity University will be the biggest private education contributor in the research in the space science. And since then, the team of Amity Education Group has been working relentlessly to fulfill that vision of honorable founder president, and we are all the times working under his great leadership. And on this occasion today especially, we are very thankful to ISPA, the particular Lieutenant General A.K. Bhatt, and Group Captain T.H. Anand Raoji for their valuable support and association, making this initiative meaningful and impactful. We sincerely value this partnership and would be very pleased to take forward the number of initiatives. Jointly, we intend to make our engagement with ISPA deeper and more sustained through similar student-centric programs, expert interactions, and joint initiative and industry academia engagement in future to realize the vision of Viksit Bharat by 2047. And we understand the space science is one of the very important area for the national priorities. And also, I would like to be shared that the Amity University is conducting a 5-day residential international interaction conference in October with the National Remote Sensing Center, ISRO, where we are expecting participation from the international experts. We see significant potential to develop similar high impact program in collaboration with the ISPA, bringing together national and international experts, industry, academia, researchers, and students on the common platform. And I'm truly, once again, I'm very thankful to, you know, to both, Lieutenant General A.K. Bhattji and Group Captain T.H. Anand Raoji for your support to fulfill the vision of Viksit Bharat and what our Honorable Founder President has been always focusing on. And our Chancellor, dynamic Chancellor, Dr. Atul Chauhan, he always believes that innovation, the creativity which students have, they can find the solutions one side to contribute to the nation building, economic development through their ideas, but at the same time, you know, bringing those ideas and solutions which make this world a better place to live. And so that the dream of that India to be the one side the superpower, other side be the Vishwa Bandhu, because we believe in Vasudev Kutumbakam, and I think those only the creative ideas and the solution can fulfill that the vision of India, the Viksit Bharat. With this, once again, extend very warm welcome to our esteemed guests, the partners, and I wish all the students a great learning for the panel discussion after the initial this thing where we have seen the Nistha Kapoor is there, Krishna Atreya is there, Mr. Akash Sinha, and Dr. Our own Dr. Shivani Verma, and the way that we have the the moderator Dr. Sudhir Kumarji, the Vice President of D-Link Space Labs, are going to give you the lot of what all the opportunities you all have, how the space science and space technologies are becoming the very important. I'm sure all of you are going to get a lot of ideas and experiment those ideas, come with the solution, innovative solutions, and so chart out your future career plan, how you would like to move with this. I extend very warm welcome to all of you. Thank you.
Thank you, ma'am, for your inspiring words and for highlighting the role of higher education institutions in nurturing future leaders and innovators in the space sector. It is my pleasure to introduce distinguished guest, Lieutenant General A.K. Bhatt, a highly respected leader and advocate of India's rapidly growing space ecosystem. Sir has been instrumental in strengthening collaboration among stakeholders across the space sector. May I request, sir, to kindly deliver the welcome remarks.
Good afternoon, Jai Hind. Founding chairman, who is online, Chairman Mr. Atul Chauhan, Madam Vice Chancellor, Madam Shukla, and the members of industry who have found time to come today. My special thanks to you, and of course, Air Vice Marshal Pawan Kumar, who is the keynote speaker today. Firstly, I would like to congratulate MIT for conducting this 1 week of Space Week, and awareness, and exhibition and other activities which are being carried out for all students. And we in ISPA, who represent the entire private industry in India, on behalf of all of them, thank you for organizing this, bringing in this consciousness to the very important next generation, which will take India forward, not to moon, but to Mars and beyond. Last week was one of the very special days in my life when I was sitting in the mission control room of ISRO at Sriharikota, and Dr. Sudhir was with me. And with bating breaths, we were waiting that this private rocket, which was being launched by the first startup in India, Skyroot, succeeds. And what a thrilling moment was it as it went up and up into the sky. And this achievement has taken place with young men where the average age is just 28. It talks of what New India is and what New India would achieve. 5 years back, when I made the Indian Space Association, and I was told to collect all possible startups and private companies in India, I was not very confident that this will happen and it will happen so fast. But today, and I remember, thanks to Dr. Sudhir, he was there, and what a help he has been to many of the startups which have grown up. We have more than 5 to 6 companies. I'm talking of startups who have launched satellites. There are 2 companies who have one orbital and one pre-orbital launch has been done. And as on today, there are many more companies coming up ready to launch rockets. Not 1, 2, but much more. And all this has happened, which we call as the new space race or the new space revolution. Of course, started again in America when 3 rich men, Elon Musk, Jeff Bezos, and one, the owner of Virgin Galactic, decided to invest in space. And they all had big dreams. And of course, Elon Musk wants human beings to go to Mars in his lifetime, while Jeff Bezos wants them to go to moon. And they are not just dreaming about it. They have put their money, their heart, and their capabilities to achieve this. I should tell you about a vision which is there, which is actually done by a study by the US Space Force. And they said, okay, let us look what will happen in 2060. And they called in scientists, experts, everyone. And okay, what is there? What will happen in space in 2060? And they came up with 8 contingencies. And I should tell you about the best contingency. The best contingency speaks and says that everything, if it happens correctly, human beings will have colonies in Mars and Moon. There would be many places in the cislunar space, that is the space between Earth and Moon, where there will be manufacturing stations, factories. Everything for the Earth will be produced in space. Energy, solar energy will be beamed down to Earth, and fossil fuels will no more be burnt. Some of them are, what I'm talking of is, will require disruption in technologies, but it is very much possible. They also say that there will be so many tourists in space that maybe people go for their marriage there. I hope I can attend some of your marriages there on the space station or in the moon. Are you ready to go for that? Okay. So for that to go and for that to happen, there are many things which we have to do in science. And there, when it is happening, India should be at the high table. I again remember the moment when Chandrayaan-3 launched or landed. Just a day before that, there was an interview, and BBC and Al Jazeera interviewed me, and they wanted to ask me questions on Chandrayaan. And before me, of course, was the real man, the chairman of ISRO, who was speaking. And he was asked what will happen if Chandrayaan-3 does not succeed like Chandrayaan-2. He said, no, I have no doubt this will succeed. The confidence he had, and thereafter when BBC and Al Jazeera asked me, I was so confident because the body language of the lead scientist in India was that there's no way we are not going to succeed, we will. And that is how it happened. And that is the story of New India, where we have to go much ahead. We have to do many more things, go to the moon, go to the Mars, and as the space economy grows up, where many of you as students here will be involved, we should be the best in the world. I remember way back in 1990 when I went first time to England, and I was driving, the cabbie asked me, oh, you're from India, you must be having many relatives as drivers around. I said, yes, I do have. 20 years later, when I went again, the cabbie asked me, you must be having many relatives as computer engineers. I said, yes, I have them. And the next time I go, they should ask me, you must be having many relatives as space scientists around. Will it happen or not? I'm sure it will happen. Wishing you all the best. And today you will listen to some of our companies which are going to take India far ahead. There are people who have started the new space race in India. Startups private companies which are achieving or are planning to achieve wonderful things. It's not the panel discussion which would be important. It would be the questions you ask them. Because many of them started just 3 to 5 years back and are making satellites. Some would go for rockets. And very importantly, some of them are doing applications, analysis, where the space economy is going to go. And of course, it will all start with Air Vice Marshal Pawan Kumar, who has been at the helm of space security for India. Because space is not only a dimension of commercial growth, but of security for the nation. And for 2 years, he has led that organization. There are many insights now when he's out of uniform that he can give you and tell you about, and the opportunities which space offers and defense space offers in India. Over to you, ladies and gentlemen. And it's been great talking to you. Thank you. Jai Hind, Jai Bharat.
Thank you so much, sir, for your inspiring vision for space entrepreneurs and motivating the students. May I now request Professor Dr. Chandradeep Tandon, Dean, Faculty of Biosciences and Biotechnology, to kindly address the gathering.
Thank you so much. With the blessings of our most revered founder president, Dr. Showkesh Chauhan ji, Honorable Chancellor Dr. Atul Chauhan, respected Vice Chancellor Dr. Barinder Shukla, Madam, who is sitting here with us. Once again, very warmly welcome Lieutenant General A.K. Bhatt, who shared his views about the Indian space sector. I also very warmly welcome Air Vice Marshal Pawan Kumar ji, and also Dr. Sudhir Kumar ji. He's here with us, and all other speakers, Ms. Natasha Nishatha Kapoor, Krishna Acharya, Akash Sinha, and our own speaker, Dr. Shivani Verma, who will also be giving addressing. Well, I'll be taking only a few minutes. I'll want to share my experience today morning. Today morning, Vice Chancellor Madam and we went to E2 Auditorium, where the project showcase competition was on. Just now, General Saab expressed, one day it's going to be, colonies and housing societies on Mars and Moon. And today, I must tell our students, Amity International School, Saket, Gurgaon, and also Noida, they had showcased a project. It was a combined effort of around 10 to 12 members, and they were in class 10th, 11th, and 12th. Look at their creativity, what they had done. They had made a whole project on the housing society on Mars. And I spent half an hour with them exclusive to learn. And I was so impressed by their innocent exuberance and enthusiasm, and also creativity at the same time. I asked them, this society will be for Martians, the one who stay there in Mars. They said, no, it is going to be for human beings. And each and every project was, the component of the housing society was divided into, well divided into various sectors, starting from the structure, starting from the health and all adequate infrastructure, including schooling. I couldn't believe. I asked them, do you think it's going to be possible one day? They said, definitely, the way things are going, maybe. I asked them, what is your approximation? How many years do you think this housing society is going to be possible? And each one of them very, very enthusiastically said, in another 30 years from now. So I asked them, your average is now 16. That means 16 plus 30, you'll be seeing this. They said, yes. So what I mean to say is this enthusiasm of the students for the Indian space sector is so contagious. Believe me, it is so contagious. One has to feel it if you go and interact with the students. And not only the school students, our MIT students were also there. Dr. Shivani Verma and her all students had exhibited beautiful, very learning projects there. So we look forward to now a very enlightening session, panel discussion with this. Thank you so much.
Thank you so much, sir, for your encouragement for the next generation of innovators and space entrepreneurs. I request everyone to give a huge round of applause for all our speakers. distinguished guests, students, we have now arrived at a prestigious moment of the session, which is the keynote program. It is my honor to introduce our keynote speaker, retired Air Vice Marshal Pawan Kumar, former Director General, Defense Space Agency. With extensive experience in strategic and defense space capabilities, Air Vice Marshal Pawan Kumar brings a unique perspective on the critical role of space technology in national development and security. With this, I humbly request Sir to kindly take the stage and address the gathering. Please give a big round of applause for Sir.
Good afternoon, everyone. First of all, I would like to thank Amity University, Dr. Chauhan, Honorable Vice Chancellor, Dr. Balwinder, Indian Space Association, General Butt, for giving me this opportunity to be here and delivering this keynote address, and that too on a very relevant topic, that is future of India's space sector, academia industry collaboration with focus on innovation and entrepreneurship. So, before we dive deeper into this topic, I think it is important to understand that how is India's space sector shaping up in the years to come. You will be really glad to know that out of 192 countries in the world, India ranks among the first 10 as far as the space sector is concerned. We are going to launch about 300 satellites in next about 5 to 6 years. After the success of Chandrayaan-3, like it was brought out, after it carried out successful landing on the southern edge of the moon on 23rd August 2023, the work is already on for Chandrayaan-4 and Chandrayaan-5. You must have seen or heard the news last week that NASA has invited ISRO to establish a base on the southern edge of the moon. This is as part of the extension of Artemis Accords. So that shows the power of India's space sector. Why southern edge? Because the sunlight is it is more brighter as compared to the other part of the moon. We will have our own, that is indigenous space station by 2035. Indians will land on the moon by 2040. And it is believed that in this entire ecosystem, about 10,000 engineers will be absorbed in next 5 to 6 years. If we just talk figures of space economy, we will be $44 billion in 2033 and about $200 billion in 2040. That is about 15% of the global space economy. While we are talking of this, because it is made in India for the world, and our engineers must go all across, like General Butt had brought out. So let me tell you global figures. At present, globe is at $600+ billion, and this will become $1 trillion by 2032. So that is the kind of scope that this space sector really holds. If you talk of startups, we had single-digit startups in 2022, and as of now, there are 400+ startups with the average age of the founder about 30 years and average age of the space team about 26 to 28 years, as was also brought out by the Skyroot founder of the launch of Vikram 1. So this is the kind of space ecosystem that we are going to see in the coming year. So if that is true, it is not incorrect to say that it is, of course, a sunrise sector, and it is not possible to achieve this ambitious program if there is no academia, industry, and government collaboration. And hence, hereafter, now we will focus on academia and industry because that is the topic of the discussion today. Now, when we talk of academia industry collaboration, there are three pillars which I think are extremely important. These are academia, these are research, innovation, and talent. There is just no choice for the ecosystem. These three pillars have to combine and effectively translate to give us viable commercial outcomes. It is only if this happens, we will be able to achieve the goals that we have set for ourselves. And this is known in the ecosystem. The complete ecosystem knows it. And there is a lot of push that has been given by the government as far as achieving this goal is concerned. I don't know how many of you are aware. Of course, Indian Space Policy 2023, I think most of us sitting here should have read it. There are programs of the government like Antariksh Jigyasa, that is for space education in schools, colleges, universities. There are programs like Antariksh Prayogshala, by which the government wants to set up laboratories in various universities. I am talking of space labs. There are CANSAT programs, model rocketry programs. So there is huge push as far as government is concerned to achieve 44 billion and 200 billion that we said. So this implies that there is a very clear resolve, there is a very clear goal, there is an intent, there is government push, and there are adequate grants available to achieve this. We have grants available through InSpace in a seed funding and technology adoption fund. There are grants available under DRDO, under various code heads to achieve this. There are grants of the government in Department of Science and Technology, that we say ANRF and RDI funding, to take the technology from TRL 1 to 3 and 4 to 9 respectively under these two schemes. So there are adequate grants which are also available to achieve. So everything is in place to achieve the ambitious goal. What is required is that the industry and academia have to collaborate. So if that is true, the common question which comes, and especially when you speak to the students, and since students are the main audience here and the focus of this discussion, the common question that comes up to everyone is that what area we should work, what problem statement we should be solving. When people talk of research, what innovation, and how do we move forward? I think the answer, if I have to give, the answer to this entire set of questions, whatever we develop, it has to be citizen-centric application. Keep in mind, space is a global common. Space is for global good. So whatever application you develop, it has to be citizen-centric. It has to be for the benefit of the mankind. And be rest assured that whatever space application is developed, it has got its strategic use, and how to use it strategically, how to take it to that edge, that we leave it to the professionals, because it is possible and it is done that way. The era when we used to work, separately for military and civil, I think that era is over, primarily because of the long gestation period of various space projects and the cost involved. So we have to work together. We have to work for dual use applications. Rather, I will keep it simple and say citizen-centric application. It is primarily because of this that it is believed that our space sector almost supports 50 government sectors. And it is true. From the time you get up in the morning, let's say, you talk of the weather forecasting, you talk of disaster management, you talk of climate, urban planning, renewable energy, border security, strategic. Everywhere, the space sector has to come in and is supported by the space program. Now to come that what problem statements the student should be working upon. First of all, I really do not know if the student is sitting here. I just went around the exhibition only for 15 minutes. I think it was my bad luck that I came late. I still remember a student telling me, sir, I want to collect the debris. It was on the right. So these are the students who are talking. They are the school students, that I want to collect the debris. And I want, because 99% of this debris market talks of getting debris back to ground. But he said, and very novel idea. He said, sir, I want to collect this debris in space and I want to get it to a mothership in space, and I want to utilize this material to manufacture satellites. Actually, I was taken aback. I really do not know whether this is feasible or not feasible. And from that time, believe me, this idea has been going across in my mind, even when I was sitting here. So these are the kind of problem statements. Actually, that is why interaction with the students always gives you positive vibes, because you come out of your normal thinking and you go into the thinking and novel ideas. So I'm not joking, but still I'm thinking of that how is this possible and how is it possible? So having said that, so as far as the problem statements are concerned, my advice to the students sitting here would be that, out of the various domains of space, if we have to divide it, we can broadly divide it into 7 domains. For example, intelligence, surveillance, reconnaissance, communications, PNT, space weather, space situational awareness, countermeasures, miscellaneous activities like on-orbit refueling and maintenance. So if you divide the space into these 7 segments, and you take any particular segment that is of passion to you, that is of interest to you, and you take one problem statement in that, the job is done. The collaboration will happen, and believe me, this will happen. So if I had to give one example in each of these domains, the areas I think which will affect the years to come, we can, and I'll give one example each just to save time. For example, the future belongs to neuromorphic sensors. It belongs to software-defined systems. It belongs to GNSS receivers, integration of LEO and GeoPNT, space traffic management and space debris, and number of stalls were there today for that. The reason is because as of now, there are about 16,000 active satellites. And if you just Google it, there are various reports available online. It is believed that will be 1 lakh plus satellites by 2030. And if the statement is true, then the dense problem of space traffic and hence the space debris management and hence the software required to track, catalog various satellites and debris. Right now, we are saying more than 10 centimeters because we can only track it. The problems with respect to space weather, especially geomagnetic storms, the problems of on-orbit maintenance and refueling, there are n number of problem statements. And more importantly, what I would like to mention is out of $44 billion industry that we will be in 2033, the major pie of that is in the downstream application, which means that we should be knowing how to utilize the data. It is believed, and it is a report, that probably there'll be so much of data by the time all these satellites get launched, we won't know what to do with this data. So now is the time that we get into predictive analysis. Right now, we are in data and pattern analysis. We have to get into predictive analysis for various solutions that probably we are talking. And hence, the combination of data analysis, predictive analysis in this case, artificial intelligence will have to come in, because without that, it is impossible. And the kind of cyber breaches, etc., we have. So a combination of cyber, AI, and data, that is a huge field in itself. So like I said, these are the areas in various domains of space. Probably these areas, if you analyze further, you will find various problem statements within each area. And that is the problem statement of the future, which will give us deep space, deep tech and high tech, research problems. And moment you work on that as a student, for the industry who is really looking to hire such talent, there is just no choice, and the collaboration will happen. And as a country, if we want to achieve, what we have, the vision that we have laid for ourselves, and actually my vision, if you ask me, my vision would be that when the entire world looks at stars in 2040, it should think of India. So if that statement is true, and if we want to achieve that, I think collaboration is the only way forward. And that is where, once again, I think the discussion that follows, I'm very sure would give us even greater and deeper, deeper ideas. So before I end, I think once again, I would like to thank MIT University and General Bhatt ISPA for giving me this opportunity. Thank you so much, Jai Hind.
Thank you so much, sir, for your engaging and thought-provoking address. Your insights have certainly provided valuable direction for our discussions ahead. and we are extremely grateful for your esteemed presence at Amity University today. Please give a big round of applause for Sir. We have now come to the panel discussion session part of this program. The title of the panel discussion is Future of India's Space Sector, Academia, Industry Collaboration, Innovation and Entrepreneurship. The remarkable growth of India's space sector is being fueled by collaboration between academia, industry, startup, and government institutions. Today's discussion will explore how these partnerships can accelerate innovation, create entrepreneurial opportunities, and strengthen India's position in the global space economy. May I now invite the chair and the moderator of the session, Dr. Sudhir Kumar, former director, Capacity Building Program Office, ISRO, and Vice President, XT-Link Space Labs, and a distinguished panelist on the stage. And thank you all the dignitaries who have graced this occasion. Thank you, ma'am. Thank you, sir. Thank you, ma'am. It's my honor to invite our distinguished panelist, Ms. Nishta Kapoor, Senior Director, India, SAARC, and Africa, and Eutelsat OneWeb. Mr. Krishanu Acharya, CEO and co-founder, Suhora Technologies. Mr. Akash Sinha, founder, Omnipresent Robotech, Professor, Shiv Nadar University. Dr. Shivani Verma, Professor, AISST, Amity University, and Director, Engineers Research Solutions Private Limited, to kindly take their seats on the stage. May I now request Professor Dr. K.M. Soni to kindly come up on the stage and welcome a distinguished guest with a Tulsi sapling. Please give a big round of applause for our distinguished guests. Thank you so much, sir. May I now hand over the session to Dr. Sudhir Kumar for the panel discussion. Over to you, sir.
Thank you. I hope the time limit would be 1 hour. Is it okay? Time limit is 1 hour? Or you have any? Okay. Thank you. Thanks for a very nice gesture by Amity University. And before actually start the discussion, probably I would like to give my remarks on the National Space Day and Week, where especially Japan kind of advanced countries, USA kind of so-called advanced countries are failing to reach the southern pole of the moon. We have done a splendid job. As AVM Pavan Kumar was telling, Bhatt Saab was telling Somnath's confidence. I was there in front of Honorable Prime Minister when Chandrayaan-3 was taking the final course of, let us say, cracking down the velocities and joining. After that, we had an interview, very nice interview in Delhi by, I think PTI or somebody was asking questions to Somnath sir, who happened to be my boss. How actually this Chandrayaan-3 was designed? He said Chandrayaan-2 was designed for a success because thinking that everything will succeed. There, this over kind of, let us say, optimism, I should say. Whereas having listened to the, having experienced the problem, Chandrayaan-3 was designed for a failure. Because every step of the thing, they assumed that it will fail, what will happen? It will fail, what will happen? So that's why he said Chandrayaan-3 was designed for failure. So prepared for failures. That is the first lesson that we should take from Chandrayaan-3. And the second thing, what he said was, one question was there, where Chandrayaan-2 went wrong and where Chandrayaan-3 succeeded. He confidently, I recall the words because I was there, I was organizing that interview as a PRO. He was telling the design Chandrayaan-3 vertical velocity, even if it is more than around 4 meters per second or something like that, it was designed. Usually when it comes to the 100-meter level, when it is breaking down the vertical velocity, even if something happens, should have, God forbid, nothing should have happened. If it falls with that speed, the Chandrayaan-3 was designed to succeed. So that is why up to that level, 44 meters per second level, definitely they designed the autonomous, let us say, systems would work. Only the problem is when you are landing. Okay, that is why with the confidence he said that nothing will happen. Even if it fails, mission will be successful. So that Chandrayaan-3 put us in the top most list in the global scenario after Martian, let us say, achievement when we entered into the Mars in the first attempt when all the advanced nations were failing. That is the genesis of this National Space Day we are celebrating. And eventually World Space Week, we know October, let us say 4th to 10th when Sputnik was put into orbit. But fortunately, we have World Space Week and National Space Week. And Amity University, amongst many universities, celebrating this one as a gesture of, let us say, giving the tribute to the Indian scientists, remembering the Indian scientists who started when nothing was there. Second World War broken, all the scientists returned to India like Vikram Sarabhai. He dreamt, he was not in ISRO at all. There was a notion that ISRO was developed. That is no, like that in COSPAR, he was a chairman. He did not have even an official designation with ISRO. But the guy who was in DAE, part of DAE, he did everything from his own house, that is PRL, he started and developed this one. It is obviously after the Independence Day, we should remember such kind of scientists, and it is our responsibility to remember such kind of scientists and learn to their success stories, especially kids, how actually when everything was denied, when the technology was denied, when nothing was there, at that time he brought the international cooperation. We brought Nikkei Apache from America, some computers from some other country, helicopters from some other country, France. Like that, we brought the international cooperation when really there was a crisis and brought this space program to India. Now, from a pencil rocket, probably, and a shell which is being carried out by cycle. Now, I happen to build the largest, heaviest structure in ISRO ever, that is second vehicle assembly building, which carries 4,500 tons of launch vehicle capable to push 1 kilometer on a mobile pedestal using a trailer. That is the capacity Indian scientists have achieved when nothing was there, when everything is made in India. Today, Made in India slogan is spread to all. But ISRO was a testimony, was a model to implement the Make in India program right now, right from 1970s. Please join your hands for giving tributes to Indian scientists, space scientists, and Indian space ecosystem. So with that note, we'll start the panel. Especially, we have very varied panelists. One is from communication, another from earth observation, another from IoT softwares, and entering into, let us say, SAR. Okay. And of course, Shivani, who was a passionate, let us say, research scholar, scientist, turned scientist, I should say, because when I visited the lab last time, I was amazed to see, I always took that example at various places. Identifying your limbs and joints with IoT and with artificial intelligence, identifying who's this guy is, even if it is limping or if it is such kind of models they have developed using different techniques. More we will listen from them. So that is the panel we have. Let me be more candid rather than reading the questions because all are stalwarts. Okay, I am picking up because learning from them in the traveling in this couple of things. So when we have the coming to Nishta, is my sister, I call it as, because that a bondage we have over years when they have requested ISRO for launching OneWeb satellites. When there was a kind of scarce launch because of the Soyuz, ISRO has come up, raised to the occasion to support them within the shortest span of time and put OneWeb satellites first time M2, M1 Chandrayaan 3, I think M2, the next commercial mission we have dedicated to international customers. Thanks to OneWeb for trusting us. I move to Nishta. Nishta, you had done a very great job bringing the OneWeb constellation, 72 constellation, rather 72 satellites. What you feel that communication era, because I more concentrate on the students, not on the technology and other things. Let us say communication occupies 40% of the entire value chain, and without mobile and without communication, nothing works in this era, especially the Gen Z batches they're sitting in front of us. If you take out mobile, that's all. They will die. Not they won't give up their mobile. So what kind of, let us say, new technologies that you see using the communication era, rather what would be your ask? If you ask a Amity University, look, what kind of let's say skills that you look in the curriculum development to develop so that our industry will grow. Can you just throw some deep thoughts on the application side?
Thank you so much. And first of all, my heartiest congratulations to the university and its management for putting up such a grand and a beautiful show. It is always pleasure to be a part of such events where students are calling the shots. So thank you so much. And thank you, General Bhatt, for inviting me here and making me a part of it. Thank you, sir. Sudhi, sir, it is always great to be with you and connecting with you in different forums. This whole week is indeed a proud week, what we are celebrating as an Indian. What we have achieved in last few years, particularly, besides what ISRO as our esteemed organization doing for a few decades, is absolutely commendable job we have achieved as a nation. Whether it is a startup ecosystem or a Chandrayaan mission, it's nothing but to feel absolute proud of. So indeed, this generation, which is right sitting in front of us, is going to take this ahead in next years to make India a real superpower. Now coming to your question, sir. Just before that, let me introduce my organization so the students can connect what we represent and what we do. I am proudly representing rather, a Eutelsat OneWeb organization, which is the only organization currently in the world which has its own geo satellites, which most of you must be aware of. And we also have our own LEO constellation. Now, LEO, of course, stands for Low Earth Orbit Satellites. So we have our own constellation of around 650 satellites, which are right there in the polar orbit at 1,200 kilometers up and, active. What does exactly do, what this constellation is trying to do, or why suddenly this space has become the new normal, what Pavan sir was highlighting. Space is no more a niche industry in our parlance, what we say. It is the thing now. And why? Why? Because of the change of the face of the communication. Now, communication is not your phones only, which is just to communicate with your friends over a terrestrial. That phone is basically your life, right? And why it is life? Per se, not an Instagrammable life, but really changing your day-to-day life in the sense because you are taking decisions based on the applications what you are using. Now, when we talk about the application, it talks about the connectivity layer. And when we talk about the connectivity layer, which is a backbone of the communication, not only, like I said, the application, but the security of the nation. Now, what we are living in the world is a very, very VUCA world, what we say in MBA parlance, the VUCA world, what we are living in everywhere, there is some or the other war. Entire world is in the war per se. So in that scenario where we are heading, what really keeps the sanity of a nation? It's the communication and the connectivity layer. And there comes the satellite or a space as an ecosystem. And hence, the space has become a new normal. So when anything is a new normal, it's like it in directly proportional to the number of opportunities and plethora of innovations, what we can do. And like Pavan sir again was, I'm taking his words that the fundamental now, the three pillars would be research or innovation, right? So because it is becoming a new normal, the innovation becomes the key for this generation. In our organization or in our connectivity as an industry, wherein we are bringing the communication through space, through LEO satellite as a constellation. What it does, it is basically because the satellites are only just 1200 kilometer, or the LEO orbit is just from 400 odd kilometers up to 1200 kilometers. So what it does is it reduces the latency. Latency means, I'm sure most of the students would be aware, the time to reach the signal on the earth, basically, right? So it opens that creative part of it. Okay, what all we can do? If we can have a quick signal, right, in a milliseconds, what all we can do? We can do a lot of IoT applications. We can do telemedication. We can do medicine. We can do a lot of basic innovations in terms of education, in terms of agriculture, in terms of logistics. Just visualize that if your truck is loaded with this communication and this application, do you think that there will be any accident because the truck is talking to the car running beside it, right? Can we reduce that? Of course we can, because we don't have to. The driver is not driving because the two vehicles are talking to each other. Everybody is connected, right? Because it is all satellite communication. That's a very small example what I am saying. And you just have to think, you just have to broaden your thinking. Now coming to the skill part of it, the skill is not that we have to become everybody, because earlier we used to think ISRO is all about scientists, which is indeed, right? And we have some huge respected scientists, and I had a pleasure of meeting a lot of them, and one is sitting right beside me. So yes, but it gives a lot of fear in a student's mind. Okay, space is all about being a scientist. Not really. That's the change of the face of this industry. You can be a scientist if you have that kind of a passion, but the people like you and I, who are not looking to become a scientist, have so many things to do even using this application in mind. You start thinking, if there is a signal from space, how I can use it? That's the simple questions you have to ask. Like, how I can solve a problem? What is the problem? There's yesterday, there is some Himachal Pradesh government, we were having a conversation, and where they're trying to connect 700 schools, right at the border, and there are some 25 students only, and they don't have a connectivity, and they're trying to create that hub. And we still living in India where the connectivity, the basic bare minimum connectivity is not there. So there's a small start of this, and huge environment changes what we are seeing. Rocket building, satellite manufacturing is just now a start, what we have achieved greatly. Now, this generation sitting right in front of us have to start thinking how we can take this next, to a next level. And there comes a lot of innovations, lot of research, and universities like MIT, which are doing a wonderful, great job, will bring in this lot of students who can be really fit for the purpose for the industry. And yes, it is a collaboration between the industry and the academia, which will make this happen. Thank you, sir.
Thank you, Rishta. Lot of things she brought out, probably I don't know how many of you have noted down. One is low latency. See, earlier, there's whether it is TV or mobile, we used to have a geostationary satellite. What is the distance of any geostationary satellite? Any guess? Very good. 36,000. What happens? 36,000 when satellite is there, it requires a huge power to transmit the signal. Now Leo constellation has come, thanks to Elon Musk. He has opened our eyes. When America of 36 crores population, when they are putting 2,700 satellites per year, 140 crore population, India, how many satellites we require? This is the question for you. Last mile connectivity, you are sitting in Noida happily getting, if you want the pizza food, you will put it by 5 minutes, they will fight 7 minutes, 4 minutes, Blinkit, Insta, so many things. You go to village, you can't even get a phone for emergency purpose. That is called last mile connectivity. Government is focusing on such kind of, let us say, essential things where you guys who are coming from villages, how actually I can put a repeatability. You take a project. In your own school, some of the classes do not get proper signal. You develop a small booster, develop it in your lab and put it in your say system and see that whether signal is getting boosted so that you will get a proper signal from the mobile or not. This kind of intuitions where household, because if you develop such kind of things, if a group of communication, electronics, instrumentation, 3 or 4 people you join together, go to your principal or dean, you ask, sir, give me a project. I request the college, first you please conduct some kind of brainstorming sessions to pull out these ideas, put a group, give a project to them, send them for industries to ideate that project and let them do in the house. It's not that the space means only satellite and rocket. There are n number of applications where your labs can do. Sitting by the side of your me, who rather converts the idea into a prototype, convert the idea into, because that is where the students' interaction has to happen. So coming to our Krishan, who is doing wonderful job using the satellite data, I always say the satellite right from mosquito to missile, you can track using the satellites. That is the leverage, that is the kind of, let us say, advantage, technology advantage what we have. Kishanu, I think what the students require, how actually, rather than going into the big jargons, how actually in a simple term, a satellite will be useful for them in the social life, in the, let us say, technology adoption and doing miracles. Can you just tell in some simple terms?
Yeah, thank you. Thank you so much. So these particular setup actually takes me to my memory lane. 22 years back, to a little more than that, 23 maybe. When I was out of physics, I actually did my bachelor's in physics. Then I was speaking with my professor, okay, what I should be, pursuing further. I was not very keen about taking masters in physics. So few options were there. Of course, taking something on the computer side, computer science side was there. But one of my professors, he said, there's a subject called remote sensing. And I had no clue about remote sensing. What remote sensing is, used to be at that point in time. So he said, okay, there's an event happening like this in IIT Kharagpur. Why don't you go and see by yourself? 23 years back. And today I'm talking so proud that I took that, journey, took a master's in remote sensing. Now I run a company called Suhora. It's a special intelligence company. We converge a lot of satellite, as you rightly said, as one of the key sensing mechanism. And we have our own algorithms, pipelines, inferencing models, which we use for strategic application like defense and intelligence. Also in dual use cases like say disaster, like say energy infrastructure, etc., etc. So, uh, so that's a kind of nostalgia. But so coming back to your question, sir. So I think problem is everywhere. You look around yourself. You as a Gen Z, we're talking, right? So Gen Z, I have huge respect for them because they're fearless. They can actually, see and visualize that which otherwise we oldies cannot even think of. So my respect goes to them, and that's why precisely if you look at problems around yourself, so we live in Noida. Look at the pollutions we have. In next couple of months there will be pollutions that literally we have to wear the mask, right? So those kind of problems are everywhere. We as a company have developed a solutions for some of the government in Haryana government and the Punjab government as well to detect where are the farms which are region of burning of the stubbles, not to penalize them, just to sensitize them. If they should not be doing this. Government has its own way of handling that. But technology today available, the video satellites we've been talking breadth and length. We have tons of satellite today. If you can put them to use, of course, through a certain mechanism where the extraction of the information happens in a directed manner, you can actually use it for better life. Right now, while you speak, Assam, right? Assam is going through a huge flood. Satellites are actually helping them to mitigate these kind of situations. So these are real life situations, real life problems, which we should look from the technology perspective. Today, the capability of first of all, AI-led extraction of informations is happening in a very, very rapid course. Second, the compute. You sir said, okay, there's tons of satellites today. We will be scratching our head what to do with the data. Thankfully, we have capabilities of extractions in the high throughput manner. Say if you have a right algorithms in between, we can break down a satellite data to a analytics in a few minutes. And if you can push it in a very, say through say Eutelsat, I'll say, push it to the users, the last mile as you say. So then you're talking in a, the actual utilization of remote sensing and space science to the real world's, real people's hand, right? So you have to start, looking around yourself. I'm just talking of the students, right? So, and I think, this country requires lot many entrepreneurs at its whole, right? So we as a country have huge amount of problem statement. If you just try to find those and try to find a business model around which people, users can buy from their, own hard-earned money. This is enough business model you can think of. If you can create a thought process, problem statement to a business process, business model, then, I think, we are this, yeah. So I think there's a convergence between technology and the, social life, as you rightly said. So, yeah, so the few of my thoughts.
I think now today people think that satellite is above us. It is somewhere it is going. Now satellite is being called as eyes and ears in the sky. Eyes and ears in the sky. I think we'll get to know more ears, probably eyes we have seen a partial ears. Today what happens when a satellite goes around, there is a sea, there is a ocean, 70% of the ocean is covered by the earth. Then clouds. Probably if you want to watch something when a cloud comes, usually this is called remote sensing is passive. When active is there through clouds, you have to penetrate and see. And that's what when the optical and the another the thing is fusion, then you will get a good image. And today the advantage of the satellite is if some kind of let's say clear sky is there, you can just take a small leaf on that one. If a different let's say pattern is there, when a leaf is stressed or not, because some of the leaves the diseases will be found out based on the stress. you can we can find out using the satellite. I agree. You agree with me, Kishan? So such kind of precise systems is available today, whether it is a mosquito control in the health sector, or it is a waste management, or whether anybody doing in a highway, whether they are properly utilizing the sand and gravel in a proper way, which is again a kind of, let us say, quality control. The satellites are being used. So I'll go to Akash. So when you have been, let's say, developing lots of software even for Chandrayaan missions kind of thing, I would expect from you, let us say, for a social life, using IoT, what kind of, let us say, satellite technologies, amalgamating the IoT technologies, or let us say terrestrial technologies, how we can leverage, what kind of skills that are required by the university to concentrate? Can you just throw some light on that?
Thank you so much, Dr. Sudhir. It's been an honor and pleasure to be here. First of all, I must say we work very closely with Amity University. In fact, Dr. Shivani and Professor Prasad have been advising us for some time. And in fact, 5 of Amity students, in fact, 1 faculty also works with us. So I think the coursework here is amazing. And today I was told that you are also launching a course in MTech in space science. So it's quite amazing because we had to go all the way to Trivandrum to IIST to find students in that space. So I think you are in a great place being in Amity. Also being the Space Week, I do want to just highlight one good trivia about ISRO. Is that, NASA and Soviet missions had been going to space for, some odd 30, 40, 50 years before ISRO sent its first mission, Chandrayaan-1, to Moon. But Chandrayaan-1 was the first mission that actually found water on Moon. I don't know how many of you know that. There is some debate on, which payload. Some payload was Indian, some was NASA payload, but it was all through Chandrayaan-1 mission. So again, kudos to ISRO, what they've done to the space industry here. Also a quick recap about my journey. I belong to Delhi here only, was at Delhi College of Engineering, then went to Carnegie Mellon, studied robotics there, worked for iRobot, Lockheed Martin, couple of NASA and DARPA sponsored projects, and then came back to India. And I got my first break through DARPA, through DRDO and ISRO. We got a couple of projects and then eventually got to work on developing the software for the lunar rover. And those of you who are into, like as I was saying, related to IoT or computer vision, I wanted to tell you that planetary robotics is another level of challenge. So once people start landing on Mars and Moon, there is another level of challenge. So for example, when we were given this task, we realized that the Moon has no colors, no shades, no texture. It's just black or white, mostly, for most part. So it is extremely difficult to create 3D out of that. However, we had to actually go back to very basic computer vision techniques, and we were able to build a very good 3D model so that the rover could find its way around and navigate. And then that eventually also helped us into bagging a contract from Indian Army through this Aditi program, where now we are creating a 3D SAR constellation. So it's essentially, think of it as Sir was saying, it will be more like ears. So it will be a synthetic aperture radar constellation that will try to build a very precise 3D map, or as it is called 3D TEMS. And one of the great things that I would say, again, if some of you, and I hope many of you are thinking of starting your own space startups, is that this is an amazing time to do that. As I think General Bhatt had also highlighted earlier, what has happened is that, and from my own personal experience, I know many of my friend companies who have gotten grants up to 300 crores. Up to 300 crore grants government is giving under RDI scheme. Then under, schemes from in space or Aditi and IDEX grants, you can get up to 25 crore grants. In fact, we received one of those. And the amazing thing is that not only the government is giving grants, you can, along with the grants, they're also giving you an assured order. So for example, in our project, we got a fairly large assured order to build a large part of world and create its 3D dam. And what happens when you get a grant along with an assured order is that then the private sector also chips in. So for example, when we raised 25 crore from government, we were able to raise another 75 from private sector, and another 100 is sort of under progress. And I think this kind of policies, this kind of environment was really never there. And so this is something, I would encourage a lot of you to look forward to. And, I'm sure many of you will become the Elon Musk and the Jeff Bezos of India.
Thank you, Akash. See, when we say eyes and ears, again to bring it to the bottom level, when a signal is passing, now you are seeing the great wars which is happening years together. India will not do anyhow like that. We'll go hit and come back. AVM sir will will vouch for the thing. And we don't extend because patafat. Okay. And how these wars are being won? Any idea? Anybody can tell how these wars are? What is the change between a conventional war and the modern war? Any communication guy? You wait. You are most intelligent guy. I'll give you an award at the end. Let these central guys will answer. What is which rather I should say which engineering discipline played a big role in winning the war? Which engineering discipline? Is it civil engineering? Any civil engineering guys are there? Or electrical? Which discipline won the war? That is not the domain of the engineering. There is no discipline. Which discipline? Engineering discipline. Yeah. Information, little bit deviation. Yeah, please. Very good. Very good. Very good. Give them a big hand. Communication. What these guys will do, intelligent people like AVM Pawan Kumar ji, he will go and identify where this radar is there. You don't have to kill the missile. If you cut that wire which controls the missile, you are finished. You don't have to go and bombard the planes. You just hit the what you call that tower, whatever is there, the control system, you are finished. So this is called ears. When a signal is radiated into the sky, you are somehow managing technology to cuts across and identifying. This is a very simple language I am telling you for the understanding of the students. When you cut the signal, you will find out where the radiations are coming. So hit that, where is the source, identify the source and hit it. Put PNT technology, GPS like GPS. We have, what is the technology, similar technology to GPS, what India has got, which is very popularly now in the news? NAVIC, very good. IRNS, okay, NAVIC this thing. Unfortunately, now we are going for multiple satellites. Next satellite is going to soon, and we'll get back the IRNS soon, okay? So that is the ears what we have. Eyes are, that is the optical and SAR. Ears are signal intelligence and electronic intelligence. Please, in your lab, you radiate some signal or a source you take and try to understand how to intercept that signal. This could be a second project for them. Shivani, you have to run that project and make it a thing that how these signals, different signals, RF signals will be, please. So you should find out such kind of projects. You please come out, ask the industry how actually we can do it some kind of let us say simulations, develop a small prototype. That is how you'll become, that could be a business model. Today, we want for India at least 50 to 60 such kind of satellites. You agree with me, Pawanji? 50 to 60 satellites that are required. If you want, immediately DSA will take it. Immediately. If tomorrow if you give, immediately they will come and give you 100 crores order. You take it from me. That is the demand business model. That is the revenue that we expect. Okay. Now I'll go to Shivani. Now having listened all these projects, how you actually wanted to shape, and incidentally, I was so instrumental in I think May 2024 to connect ISRO with Amity University We had a marathon workshop at Bangalore. Shafali knows it. And after that, I do not know how many projects have been rolled out, how many projects have been concluded. I hope it should have been done in a nice manner because I retired. I am not pursuing those things. I feel that projects should continue forever. And every year, at least 20 to 25 student projects you have to initiate. We are all there. Ishanu already volunteered. Akash definitely will volunteer. I will volunteer. Please send the students to the industries. We will identify, ISPA will find out 20 to 25 industries where your students can be deputed, understand the technologies and put the technology. You will be potential startups to become COO, CTO, CEO, CFO, whatnot. See, XO, X stands A to Z. Okay, I'll go to Shivani. Shivani, what is your preparedness? How you expect industry to help you? What kind of roadmap, let us say, you prescribe from this platform to ensure that the space technology and space sciences will be promoted through Amity?
Thank you, sir. Very good afternoon to all. It's really an honor being a part of this panel discussion. So I would say that we are gradually moving from Atmanirbhar Bharat towards Viksit Bharat. And I believe every university has the capability to come up with a very good algorithm. They can go for making of very good prototype. But the real challenge is how to convert this low technology readiness level prototype into a validated technology. That is the main challenge that we are facing. How to protect its IPR, how to demonstrate it in real, required environment. That is the main challenge in front of academia, where we need industry to help us out. Because now we are thinking that the question is not what should be the research academia should be looking forward to. Academia is mainly concentrating on the research problems, which can later on be taken up as good technological platforms, which are good commercial platforms. I'll give you an example. We are having lots and lots of satellites out there. We are having number of sensors, and we are getting good amount of data. So if we are getting so much of data, the next commercial opportunity should not be going for another source of data. The next commercial opportunity would be going for some kind of software that can be used for maybe detection of anomaly. Can we make our spacecraft, our ground stations more intelligent that anomaly is autonomously detected? So these are some questions that we should start addressing. And here we require the need of industry. And we are having our industry friends sitting here. So I request them not to consider academia just as a talent provider, because academia can provide something which individual industry cannot develop. For every technological, domain, like we are having multidisciplinary faculty, we are having lots of students, we are having labs, we are having a good computational facility. But then we need industry to guide us how to interact with the customer, how to understand the customer requirements, how to understand the constraints, the regulatory mechanisms. So this is the support we need from industry to develop our products into commercial technology platforms. That is the support we are expecting. And government is already providing support, like we are having InSpace, which is promoting private players, just that more integration with academia is required, I think. And NEP 2020 space policy, Indian space policy is also recommending it. So yeah, that is the support we are looking forward to. Yeah.
I fully agree with you. The entire thing starts from problem statement. When the problem statements are found, I'll just take one example of Ramji Foundation. There's a Kuppam, there is in Andhra Pradesh. I went for a visit. They're all kids, 8-year-old, let's say 8th class, 7th class kids were there. And I also visited one university in Pune, because I'm not remembering the name of the university, where the engineering students are sent to villages for identifying some social problems. These social problems, let us say somewhere potholes will be there, somewhere mosquito breeding, somewhere water flow is not there, somewhere groundwater resources is not there. Even to well, the technology is available. You can ground penetrating radars, you can put it and you can identify where exactly the water is there. So such kind of technologies which are very common use, probably we have to, this kind of culture, I always nurture that. Please send a batch of sociology people, whether it is a microbiology or whether it is health system or whether it is agriculture, whether it is a water resource management, or it is a, let us say, traffic management. Everywhere the space technology, let us say, can be utilized or leveraged. Please, I suggest Amity University such kind of people where you have autonomy in giving the credits to the students as per the NEP program. I request a group of people may be sent for villages or may be sent for their own villages, identify the problem, come back and say that the problem statement, put a group of lectures to convert the social problem into a technology problem. After that mathematical problem, after that software, giftware, hardware and all these things will come. I think such a kind of things, if you can initiate, I'm telling you, it would be a great service to the nation, identifying the problems, coming back, brainstorm, convert them into engineering solution, give them projects in a groups. I think that would be the right choice, because without use case, no technology, no innovation, without commercialization, it will work. So I fully support with you. Probably, yeah, Kishore, please.
So, thank you. I think Dr. Verma's words are, music to my ear. So we as a company, we in front of us, at least, at any point in time, significant amount of problem statements which we deal with, which has to be generated from the scratch. It's not readily available capabilities out there. You just adopt it as is because of the heterogeneity of the country's need. First, second, the technology itself is evolving. So you have to really, go beyond a certain, point in time. So academia and Suhora's collaborations, I'll just, touch upon. VITES Pilani, TC, Thiagaraj College of Engineering, Tamil Nadu somewhere, Triple IT Delhi. These are three organizations we are working with at this moment, various different sectors. TC, I'll just, touch upon what we do with them. We are working on a capabilities for large area insert monitoring solutions, which combine synthetic aperture radar on the insert side. Also, it requires a IoT sensor to be, supercharged with, because some of the cases, if it is a very, very, sensitive infrastructure, it has to be, the latency has to be very, very, quick. So with them, we are, generating a capabilities called a GBSAR, ground-based synthetic aperture radar, which sits in a locations. It scans for a scan around 10-kilometer radius. It looks for a, ground movement in a vertical, directions in every 10 seconds. And if you now think for a moment, you have our so many array of satellites, and you have a network of these GBSARs installed in our Himalayas, in our as a strategic locations of defense importance, and you combine these together. So now sensing solution is solved. Now then comes what ma'am is also saying. We have to look for a capabilities algorithms which can decipher information out of the data we generate. Right? That's another problem in front of us. We are already working in a solutions called, been working on this for some time, called Centra. It's a ISR operating system. So bring any sensing mechanism, be it satellite, IoT, IoT, drones, etc. It can decipher information deterministic to a problem statement, say national security, or say disaster, or in this case, say some of the landslide prone, or say analytics, etc. So we'll be more than happy, ma'am, if we can do this together, because we already, as you rightly said, the validations of a problem statement is the gap, right? We mimic often as a representative of the user, in this case, say national security or the Minister of Defense users. We know their problem statement. We live them every day and night. We, of course, declassification has to happen. Some of the information which is not to be shared will not be shared. But of course, we can lay out a problem statement in front of you. We can work with you to create some prototype, and IPs, you mentioned of the IPs, right? So IP, I think uh, we, we understand if the IP is of a certain person, it has to be with that person. So I don't think that's an issue, at least the new array of these space startups, we think this way. We wanted to give the deep credit to whosoever has come up with. So, I think, this, I'll say, cross pollinations of industry and, academia is happening and can happen, even further better manner.
Thank you, Kishore, for immediate and sporadic reaction. Nishta, I think one way or other, directly or indirectly, you were in touch with Bharti Airtel, but you part. And Bharti Airtel has got a beautiful STEM and outreach programs. Can you throw some light? Because I told you, I'll ask some questions, okay, which are very not prepared so much. See, in this scenario, the corporates have to encourage some STEM programs, student outreach, taking them. Can you throw some light, some of the programs, what Bharti Airtel operates and gives, and such kind of opportunities, whether is possible for these students to explore?
Yes. Sure. Whatever in my capacity I can share, I'll do that. So, our organization, Bharti Enterprise, is of course Airtel. Everybody knows the name. This organization keeps, engaging with the industry programs in terms of students engagement program. So they have the AI lab, they have a digital lab, wherein they keep conducting the number of projects, the IT projects and the innovation lab they have, where they invite students. So there is, as an organization, there is certain, I would say, commitment towards the society, which they continue doing. And there are so many multiple projects running. As far as UTLSET as an organization is concerned, we are, of course, Paris headquartered and London headquartered organization, where we do have our global programs, wherein we come up with annually, a program wherein students can submit their projects for the communication industry, and the winner, whosoever is the winner, it's almost 3 to 4 months long program, wherein we select top 3 programs or the projects that we actually commercialize. So last year there was a group of students from University of Cambridge who won that. Now that particular application we are already making a part as our payload. So these are the things as an industry we keep doing, and we would want to do and love to do as it, in India as well, as soon as we go live in the nation. So we are looking forward to such opportunities where we can directly come and invite students, let's say from Amity University itself. But I just take one more minute, and I would like to remember the Honorable Prime Minister's vision, where he says that build in India and build for the world. Having worked in Africa extensively, I can assure you, guys, that whatever you do here, there is a huge market out in the world. The entire continent of Africa is literally crying out loud for applications, the solutions, the opportunities wherein they can have such a solution which can help them build their life. Africa is yet to grow, of course, right? So please keep this in mind. Whatever you are thinking, what you are making, what you are ideating, keep that global aspect in the mind when you are doing that.
Thank you. I think Amity has got multi vertical sections across globe. I think I could see. I think you are given a clue that Africa should be the next journey. I think Chauhan sir must be listening to us. It is a new phase you have started. And as he says, let's say many corporates like Microsoft, AWS, they are opening their data sets and giving the credits for the students. I do not know how many of you know about the cloud access at free of cost credits. Please, I do request you to please enroll for such kind of things and make use of such kind of corporate resources which they are throwing for the students. I just got last, Akash, what now you're seeing, what kind of opportunities, let's say, use cases in your, let us say, experience, what at student level you can suggest the students to come out and work with the industry?
I think this is a great discussion, and uh, what we've seen also, like if you see in some other countries, like in US, you will see corporates often have an office inside the campus. Like where I was at Carnegie Mellon, there was an Apple office, there was a Microsoft, IBM, Google. They all had their own little tiny labs, and there were, one or two full-time people from the company working there, along with students, along with faculty. I think that model maybe the time has come that India also looks at that, because I think one of the problems that we face while working with academia is the constant interaction, and then sometimes that loses space. And so, how do you ensure that? And one way would be if we find these ways where you actually run a small office, or maybe even a larger office if it demands, out of the university. So that's one of the thoughts. But coming back to what students can do, and I do want to sort of incite a bit of curiosity, especially related to the technology that we are developing. So coming back to what we were doing, we are building what we call as would be world's probably highest resolution 3D SAR constellation. And so what it would mean is that you'd be able to map the entire world in 3D at a very high resolution and a very high geolocalization accuracy. And so why that matters is that if we were to, let's say, select a target across the border, if we had the exact 3D map with exact geo coordinates, we'll be able to simply fire and forget with that coordinate, if we had that with us. And even help our, maybe even our fighter aircraft fly. Now, the way that technology works is that there is synthetic aperture radar, and radar you can think of, it is essentially still just a radio. But then what happens, in order to capture 3D and to do it accurately, you need to fire two satellites and you need to do them simultaneously, or almost simultaneously. And the two satellites need to talk to each other as well. And so that if they are going to take a 3D picture of the same area, you need to have 3D signal, you need to have radio signals coming on the same region from two slightly different perspectives. And when you do that, 3D in radio signals is not as straightforward as doing it on camera, because you have large number of radio waves and you need to actually catch the phase, and you need to find the phase differences, and you generate a what's called a interferometric pattern, which tells you the height difference. So it's an amazing technology. You get exposed to radio waves, you get exposed to interferometry, to a large amount of data processing. And so if you were to sort of look into a technology like this, I would say at your stage, I would say each of you should probably develop one good technical skill. It doesn't matter what exactly it is, because in space everything comes handy. Maybe you are a great programmer, maybe you are great with antenna designing, maybe you are great with data processing, and nowadays you have some great courses over here. But I would say to every student, I think you must become good with some technology and become really good at it. So take the university courses, take even other online courses that might be available. Try to find an internship in the same related area, but don't need to lose your focus. You don't need to learn everything to get into space. Find your, what you are truly interested in, find what you're enjoying and you find interesting, but become really good at it. And it's especially going to matter a lot now with AI coming into everything. You will see that it is going to affect the environment, but there will always be place for experts, at least I would say for next 5-10 years. We don't know where AI will be after that. But for the next 5-10 years, if you're an expert in your field, nobody trusts AI blindly. So you can use AI as an assistant, but eventually you still go to an expert to verify. So my advice is just become an expert at something that you're really good at.
Thank you, Akash. I think we had very nice discussion. And as a concluding remarks, The technology is only the solution for resolving your crisis, because we were somehow very happy. We lived our life and entering into retirement, but your journey starts with all problems, energy problem, then food problem, pollution problem, so many problems. It is your duty to find you to be comfortable. That the technology, that's what our honorable Prime Minister always says. The technology should be the solution. Today he mentioned, today sitting here, you are able to control your office in the Singapore. That is digital twins. Building elevation models, he pointed out. If such kind of building elevation models are there, you can do wonders. Today, I was given to an understanding, one of the communication company, leading company, has got in all cities, how many floors are there in a building, how many users are there for internet, how much consumption is there. To that extent, data is available for the building standards. Now, new technologies are coming, swarm technologies, let us say constellations, let us say ISL, internet, inter-satellite communication links, laser technologies, optical technologies, hyperspectral, so many technologies. It is immaterial which engineering you are studying. For a civil, the younger brothers are there who wanted to build the habitants on the moon and Mars. Please go and adopt them, adopt the civil engineering practices. Material science, which is lagging, India is lagging. Materials, very high pressure materials are required. If it is chemical engineering, entire rocket is entire build up with the chemical engineering. Whether it is communication engineering, instrumentation engineering, your electrical engineering, you take any name of the engineering, you will find a kind of, let us say, component in the space. Please, all of you, please come to some kind of form, some groups, start discussing what social problems, what technological problems around you can solve. Come to the professors, go to your entrepreneur cell, ask them for funds, ask them to for you to take to industries, get to know, energize yourself, become each and every one fellow should become an industry. That's how you can beat China kind of, let us say, organizations. The India should become the manufacturing hub for the entire world. I think Nishta wants to say something.
Just one, because that one word has not come in our discussion, is the maritime, the marine. It's a huge potential for satellite. The entire marine life, it's waiting to be exploded with the satellite kind of application. So I just wanted to add.
Yes,
that,
yes,
sir.
blue economy. She's talking about blue economy where government is telling the semiconductor revolution is coming. We have gone IT revolution, BT revolution, all these things have gone. Now blue economy is the new phase. The treasure is there below the seas. Treasure. That treasure we can explore rather than some foreign people coming out to our international waters and looting the revenue. You can do wondrous things. Please, the sky is not even limit for you kids. Please come out. And I profusely thank all the panelists and students and faculty members patiently listening to us, whether sense or nonsense. I think that you have to reciprocate with your claps, please. Thank you. Thank you.
We are extremely thankful to our esteemed moderator and all our panelists for such an insightful and enriching discussion. So may I now request Professor Dr. Chandradeep Tandon to kindly join us on stage. And I would request Dr. Sudhir Kumar as well to step forward while we present mementos to our panelists. Please give a big round of applause to all our panelists. May I request Professor Dr. K.M. Soni sir to also join us on the stage. Thank you, sir. May I now request Professor Dr. Chandradeep Tandon and Professor Dr. K.M. Soni to kindly present a memento to the moderator, Dr. Sudhir Kumar. Please. A big round of applause. I request everyone to pose for a group photograph. I request all the panelists, moderators, and the distinguished guests to kindly step forward for a group photograph. I also request Dr. Shifali to kindly come up on the stage and join the photograph. Thank you. Thank you, sir. Yeah. So we have now the most exciting part of the ceremony, which is the distribution of awards for the students. I apologize, sir. I request you to please come back on the stage. For this, I request Lieutenant General A.K. Bhatt, AVP Pavan Kumar, and Dr. Sudhir Kumar to kindly be on the stage to present awards to the winners. So we are calling the winners for the essay writing competition. So on the third place, we have Miss Vidisha Sharma, Amity Institute of Information Technology. Please give her a big round of applause. Miss Palak Chaudhary, Amity Institute of Aerospace Engineering holds the second place. Miss Palak Chaudhary, quickly, yes. A big round of applause for Palak. And the first prize goes to Miss Soumya Dwivedi, Amity Institute of Space Science and Technology. A big round of applause for Miss Soumya. I now request Dr. Sujata Pandey to kindly announce the winners of the space exhibition competition. So the winners for the for space exhibition competition, we have first the winners from the school. So first position goes to the team Orbital Shield, Amity International School, Noida. And the students' names are Anand Gupta, Akash Pandey, Abir, and Kabir. For this, I request Dr. Shifali from Abstitia to please receive the trophy on their behalf. Second position goes to the team Space Trash Autonomous Scavenging and Handling System. The names are Adhiraj Kumar, Sudarsh Kothari, Nimit Kumar, and Ariz Khan. Please give a big round of applause for the second place winners. Okay. No. And the third position goes to Project Guard X Safety Innovation, Amity Vasundhara. The students are Kavish Baheti and Arav Kalra. So please give a big round of applause to the students. Now we have teams from the university. The first position goes to Project Multilodal Interactive Robotic Assistant from Asset. The students' names are Faizan and team. A big round of applause for Faizan and team. Amity School of Engineering and Technology. The second position goes to project name Solid Motor Rocket and Drone, Amity Institute of Aerospace Engineering, and the students are Mark Joseph and Utkarsh Pandey. A big round of applause. Third position goes to Project Sustainable Water Energy from Amity Institute of Biotechnology. And the team is Satakshi Kashyap and her team. A big round of applause for AIB. Satakshi, please come forward. Thank you, everyone. We would now request Professor Dr. Chandradeep Tandon, Professor Dr. K.M. Soni, and Dr. Shifali to kindly stay on the stage as we felicitate our distinguished speakers of the event. First, AVP Pawan Kumar. A big round of applause for Sir. May I now request Lieutenant General A.K. Bhatt to kindly come up on the stage. Please give a big round of applause. May I now request Group Captain T.H. Anand Rao to kindly come up on the stage and receive the memento. Please, sir. Thank you, sir. Thank you. As we approach the conclusion of today's program, may I invite Professor Dr. K.M. Soni to kindly deliver a vote of thanks.
Ladies and gentlemen, good late afternoon. It is still not 5 p.m., so it is late afternoon. So good late afternoon. Esteemed dignitaries on the dais, distinguished guests, senior leadership, faculty colleagues, researchers, and most importantly, our dear students. It gives me immense pleasure and privilege to propose the formal vote of thanks on this special occasion marking the culmination of India Space Week 2026 organized by Amity University, Uttar Pradesh, Noida, in collaboration with the Indian Space Association, ISPA, under the inspiring theme Space Education and Research. First and foremost, I extend my heartfelt gratitude to our Honorable Founder President, Sir, for his visionary leadership and for fostering a culture of education, research, innovation, and nation building. His vision continues to inspire us to prepare our students to contribute meaningfully to India's technological advancement. I express our sincere gratitude to our Honorable Chancellor, Dr. Atul Chauhan, for his constant encouragement and for providing our students with opportunities to explore emerging areas of technology and innovation. His vision of empowering young minds continues to motivate us to strive for excellence. I would like to place on record our sincere thanks to our Honorable Vice Chancellor, Dr. Balwinder Shukla, for her inspiring opening remarks and continued support towards strengthening Amity's engagement with the space sector. We are deeply honored by the presence of our distinguished guests and eminent speakers. Our heartfelt gratitude to Lieutenant General A.K. Bhatt, Air Vice Marshal Pawan Kumar, and Dr. Sudhir Kumar, and Dr. Tandon also, for sharing their valuable insight and inspiring our students. I also sincerely thank all the distinguished panelists, Ms. Thakur, Ms. Kasanu Acharya, Mr. Akash Sinha, and our own Dr. Shivani Verma for their valuable perspectives on the future of India's space sector, academia, industry collaboration, innovation, and entrepreneurship. Your participation has truly enriched the discussion. India Space Week has been a wonderful journey, beginning with the essay writing competition on space technology in India, followed by the workshop From Earth to Space, exploring our future beyond Earth, and culminating today with this insightful keynote and panel discussion. The enthusiastic participation of our students reflects their curiosity and growing interest in India's space ambitions. A special word of appreciation goes to our students who are the heart of this initiative. Your enthusiasm, curiosity, and innovative spirit gives us confidence that the future of India's space sector is in capable hands. I also congratulate all the award winners and participants for their achievements. I extend my sincere appreciation to all faculty members, coordinators, and organizing team members whose dedicated efforts, planning, and coordination made this program possible. We are also grateful to the administration, web and IT support, also ESCO studio team, media department, security, and other support team for their valuable assistance in ensuring the smooth conduct of the program. Finally, I thank each and every one of you for being a part of India Space Week 2026. Let us continue to inspire our young minds, encourage research and innovation, strengthen academia industry collaboration, and contribute towards realizing the vision of a strong and self-reliant India space ecosystem. With these words, I once again extend my sincere gratitude to everyone who contributed to the success of this program. At last, I want to congratulate the organizers of this India Space Week, especially team from Apistia, led by Sefali, Kavita, Kamakshi, and others, and including the chief coordinator Sanjay Singh, Shraddha Pandey, and other coordinators Natasha, Mahima, and Anil Sarawat for conducting this event successfully. Thank you and Jai Hind.
Thank you so much, sir. With this, we come to the end of today's program and celebrations of India Space Week 2026. On behalf of Amity University of Uttar Pradesh, Noida, and the Indian Space Association, we extend our heartfelt gratitude to all our distinguished dignitaries, speakers, panelists, faculty members, students, organizers, volunteers, and participants for making this event a resounding success. And I request all our esteemed guests and speakers and award winners to kindly join us for a group photograph and later on for high tea in F2 Lounge. Also, the participants of the essay competition, workshop, and space exhibition will receive their e-certificates from their chief coordinator. So with this, have a great evening and happy Indian Space Week.